Hi guys, am I audible? If I'm audible, give some response in the chat box so that I'll know that we are live. If you're able to hear me, give some response in the chat box. I'll also get to know who all are there in today's session in that way. Perfect. I think we can start. Okay, a bit of introduction to what we're going to do today. So we are taking up this series of level 1 questions of late in different chapters. So today's topic is time and work. We're going to pick up a series of level 1 questions, but your concept should be really strong if you have to solve them quickly. So you might not have too much time to solve those questions. So it's going to be about speed, how well you're clear with the basic concepts and how quickly you're able to apply those concepts to get the questions right. So questions are going to be basic, but we are also going to have a live quiz which is going to go parallel to this. So if you're there in the live session, you will be able to take those live quizzes. And to go to the live quiz, click the first link that you see in the description down. And you'll be able to see a live quiz named Time and Work, and click on that and start the live quiz. I haven't initiated the first question yet, but that will go parallel to this. So you'll be attempting a question there, coming back here, looking at the discussion, going back, attempting the question, and so on. So that's how the thing is going to go. If you are looking at the discussion as a recorded discussion later, if you're not there in the live session, then you might have to just follow along with the video. The questions will also keep flashing on the video. Only thing is you'll not be able to participate in the quiz and see your name coming in the leaderboard and so on. Great. So let's start. Let's start with the first question. If you haven't visited the place yet, please click the first link in the description and you'll be able to see upcoming live quizzes. And under that, the quiz for today is time and work live quiz. I'm going to activate that quiz now. You should be able to see the first question up in the quiz. There should be 10 questions overall. And I have started the quiz. The first question should be up in the quiz. See if you can answer that. And the question is up on your screen here as well. Great, the time is up. Let's see what is the status of the leaderboard at the end of this question. Good number of you have got it right. Triveni is on top, followed by Sandeep, Bharat, Navam, Sashi, Sashwat, and Isha. Okay, let's see how we can approach this question. There are multiple ways to approach this question. So let's say I'm sitting in an exam. I'll tell you what I would have done to solve this question first. Okay. So if I'm sitting in the exam, the garrison is provided with a ration of 72 soldiers to last for 54 days. For how long would the same amount of food last for 90 soldiers? 72 soldiers, 54 days, then for 90 soldiers. So I can do 72 into 54 by 90 to find out for 90 soldiers how long it will come. Now, when you reduce the individual ration by 10%, now this is where product constancy comes into picture. So if you have a product where one is reduced by 10%, so 1/10 reduction, so the other one should increase by 1/9. If I reduce something by 1/10, the increase should be 1/9. This is product constancy. I'm going to explain that in detail. Don't worry. I'm just giving my thought process if I'm sitting in the exam. So 1/9 I should increase. So I should increase it by 1/9 because of this reduction of 10% in ration. So 1/9 increase means it will become 10 by 9. Okay, so now let's simplify this. If I cancel certain things here, let me just change the color once. Yeah, if I cancel certain things here, 0 and 0 are out. 9 will cancel this. That's going to be 8 times. This 9 will cancel this. It's going to be 6 times. Answer should be 48 for this question. So that's what I would have done if I'm sitting in the exam. Okay, now let me explain this in detail as to what I did here. Okay, there are two methods which we can follow. I'm trying to club both the methods and solve here. So one method is input output. So let me explain that in detail. I've explained this in detail in the concept classes. What is this input output logic? So what we can do is we can look at the various aspects that you have in this question. One is soldiers, days, and the ration. So let me put it here. Soldiers, days, and the ration consumption ratio or consumption rate. These are the three things that we're dealing with in this question, right? So initially there are 72 soldiers. Then the food will last for 54 days. I can say consumption ratio is, let's say, 100%. Okay. Then it's going to change. The number of soldiers is going to change to 90 soldiers. We'll have to find out how many days, while the consumption ratio reduced by 10%. So it's going to be only 90%. Okay, 100%, 19%, when put as 190 also doesn't matter. Now, when you are looking at an input-output approach, you'll have to classify each column as input or output. Generally, what are taken as input? Time and labor in a work situation are taken as inputs. So in this case, number of soldiers is like labor, that's input. Days is definitely time. Rate of consumption of the ration, that tells something about your labor. So it's also like a part of labor. So each of this is an input here. And the output is the basic ration that these guys are consuming. And that's constant for both the cases. Let me put it as R and R. Okay. Now the trick here is product of all inputs in the first case by product of all inputs in the second case should be equal to output in the first case by output in the second case. If we just simplify that, we will get the answer for this question. So let's do that. So 190. So this is basically like having 10 by 9. If you see, that's exactly what we got here, right? 72 into 54 into 10 by 90 into 9. That's what we have got here. If you solve this, we will get the value of question mark to be 48. That's one particular way to solve this question using input-output approach. Okay. Now the other approach is completely going in terms of product constancy. So let me show you that approach as well. Okay, please type I if everybody is clear with the input-output approach that we took to solve this question. Perfect. Now let's look at a complete product constancy based approach as to how we can solve this. Let me clear this off in the meantime. Okay, one thing that you should remember as far as product constancy is concerned is whenever there are two numbers which are getting multiplied, okay, And if one is decreased, okay, if one is decreased by something like, let's say 1/10, if one is decreased by 1/10, the one that is getting increased to nullify that will be equal to 1/9. Okay, if I'm decreasing something by 1/10, the corresponding increase should be 1/9. In general, we can say if the decrease is a by d, the increase should be a by d minus a to nullify that decrease. The opposite also we can see. So if I am increasing something by a by d, like I'm increasing 1/10, then I have to decrease 1/11. Then my corresponding decrease should be a by d plus a. Now, these are things, if you can keep in mind, can come really handy in certain questions. Okay, now so if I'm just going to apply the product constancy concept here, let's see how we would have solved it then. Okay, initially they gave 72 soldiers. For them it will come for 54 days. Now I'll have to find out for 90 soldiers how many days it will come. First of all, the soldiers number has been increased by what? So from 72 it has become 90. So that is a 1/4 increase in the number of soldiers. So if I increase the number of soldiers by 1/4, can anybody tell me what will be the corresponding decrease in the number of days? Based on this, let me see how many of you are able to come up with that. If I increase the number of soldiers by 1/4, what should be the corresponding decrease in the number of days? Look at this. 1/5 I should decrease, right? So this value, that 72, will not remain, sorry, this 54 will not remain as 54. It will become 1/5 lesser. So it will become 54 into just 4/5. So this is something you can do in your mind itself if you're really confident about these things. Okay. So in my mind, when I see that 72 has become 90, okay. So 54 will become 54 into 1/5 less, that is 4/5. Great. Now coming to this one. So here this is getting reduced by 1/10. So the other one will increase by 1/9. 1/9 increase means what? It will become 10/9 of itself. Okay. Now you can simplify this and get your answer. So this is a particular way to solve this question. So let's cancel this. You'll get 2. If I put this, you'll get 6. 6 into 4 into 2. You'll again get 48. Okay. So what I have done here is like, the combination of both. Here I took product constancy. Here I took an input-output approach. So that is the advantage that you get when you know multiple approaches to look at a question and you're really clear about all of those approaches. Okay. So based on product constancy, this is all that you have to do. Okay. Please type 2 if you're clear with both the methods. The one was input-output. The next one was product constancy. If you want me to repeat any of this, please type the number. Type P if you want me to repeat the product constancy method. Type I if you want me to repeat the input-output approach. Perfect. Now let's move forward. Now when you can put when you can put product constancies, as long as you know all the values given here are products on the same side as far as input is concerned, because you will be multiplying all of them. Number of soldiers into number of days into efficiency is equal to total ration consumed. So these are all going to be on the same side. That's why I'm able to apply product constancy here. Okay, great. Let's move to the next question. Okay, let's go to the next question in the quiz. I'm going to the next question in the quiz. The next question is up in the quiz. The next question is shown here on the screen as well. This came in Snap 2018. The question is very simple, but I want you to understand that these kind of questions do come in exams. Has the second question come in your quiz, guys, or it has not come? Okay, it has come. Just refresh it. If it says the quiz is over, just refresh it. The quiz is not over yet. Just refresh it once. Does it say the quiz is over? Okay, just give me a minute. Let me check. Did you refresh it and it says the quiz is over, or what is the say? Did you refresh? Please refresh once. It's all right after refreshing. Okay. Okay, it's possible that some of you might not be able to give your answer for this question because of this refresh issue. That's okay. Let's look at this question. It's a very simple question. Let's see how we can solve this question. So this came in Snap 2018. A is able to do a piece of work in 10 days and B can do the same work in 15 days. If they can work together for 4 days, what is the fraction of work left? Okay, so A and B, the number of days is 10 and 15 for each one of them. I can take LCM of these two, which is 30, and assume that to be the total work. So this is my assumed total work. Now if I calculate their efficiencies, 30 divided by 10, it's 3, 30 divided by 15, it's 2. So their efficiencies is going to be 5 units per day if total work is 30 units. Now these guys worked for 4 days. So 5 into 4, they would have done 20 units. Question is what fraction of work is left? So 10 units is left. Total is 30. So 10 by 30 or 1 by 3 should be the answer for this question. So 1 by 3 is the answer. This question is very simple, but I wanted to show you that this question came in Snap 2018. So do these kind of questions also come, but you got to be really quick in these kind of questions. Please type 1 if everybody is clear with how we got option 1 as the answer for this question. Great, let's move forward. I'm moving to the next question in the quiz. The next question is up in the quiz. It's up on your screen here as well. Okay, I think something is happening with the quiz today because I think it's again showing the quiz is over, right? Something is going wrong. I'm not sure what exactly is going wrong. Yeah, there is some issue today because it again refreshed the leaderboard. Should not have refreshed the leaderboard. I don't know why it refreshed the leaderboard again. Just give me a minute. Let me quickly just set it up. It's possible that I pressed the button wrongly while taking the quiz. Okay, so let's solve this question. Can you refresh once in case you are still solving the question? Refresh once. Probably now the issue should be resolved. I might have pressed end quiz instead of clicking on next. I generally navigate the quiz in the laptop. I'm doing it in the iPad. So maybe when I'm looking this side, that's why I must have pressed something wrongly. Just refresh once and see if it is showing fine. Okay, I think there is some inherent problem today. So what we will do is I will take the future questions. Yeah, again, the same issues coming. I might have to troubleshoot this one. So what I'll do is the future questions, we will just do it on the screen itself. Okay, we'll not go to the quiz. We'll just do it on the screen itself and see how you guys are able to respond just on the screen itself. Okay, let's try and solve this question. Pipe A can fill a tank 3 times faster than pipe B. When both the pipes are opened, it takes 54 minutes to fill the tank. If only pipe B is operational, how long does it take to fill the tank? Okay, pipe A can fill a tank 3 times faster than pipe B. So if I'm going to put efficiencies for the two pipes, A and B, I can say A's efficiency is going to be 3 times faster. So I'll have to put efficiency of A as 4 and not as 3 times faster. So A's efficiency is 4, B's efficiency is 1 unit. When both the pipes are open, it takes 54 minutes to fill. So when both the pipes are open, they will do 5. At that rate, they take 54 minutes. So that will give me the total work. If only pipe B is operational, how long does it take to fill the tank? Pipe B efficiency is 1. So I just have to divide this by 1 to find out how long pipe B will take to fill the tank. So that is basically 5 into 54. So half of 54 is 27. So 270 should be the answer for this question. Type 2 if you're clear with how we solved this question. Type R if you want me to explain this in detail. Okay, I'm going to quickly repeat how we approached this question. It was initially given that pipe A can fill a tank 3 times faster than pipe B. So if pipe B, so the difference of their efficiency should be 3 units. Okay, so I can say efficiency of A by efficiency of B. If B is 1, it should be 3 times more than B. So the difference of these two is 3 times of B. So this will be equal to 4 in that case. Okay, this is something that you have to understand because 3 times faster is given. Now, the other way in which this could be given is 3 times, let's say pipe A is 3 times as fast as B. If they say A is 3 times as fast as B, in that case, we would say efficiency of A by efficiency of B is 3:1. But here they have given 3 times faster than pipe B. So in that case, you'll have to go for 4:1. Please type 4 if everybody is clear with why we are going for 4:1 in that case. Three times faster. So the difference is 3 times of B's value. Okay. So as the efficiency is 4:1, I could just take A's efficiency as 4 itself and B's efficiency as 1 itself. If you want to play it safe, you take it as 4x and 1x. 4 itself and 1 itself. And when they both are working, it takes 54 days. So sum of this will give the total efficiency of these two guys into time, which is 54 days. That will give me the total work. So what I've got here, 5 into 54 is the total work. Now, I'll have to find out if B is operational, how long in minutes does it take to fill the tank? So total work divided by B's efficiency will give time taken by B. Okay, so this is total work by B's efficiency, which is basically 5 into 54. That gives me 270. I hope it's clear for everybody now. Please type 2 if everybody is clear now with how we got the answer for this question. Okay, just give me a minute. Let me see if I can now set the quiz up once again. Just give me 1 minute. it will get rid of your first three options, but we can at least take what comes after that. So I'm going to delete that particular quiz that we are doing, and I'm going to recreate a new quiz because something already happened in that quiz. Okay, just refresh your page, guys. You will be able to see another quiz. Just refresh your page. You'll be able to see another quiz which says it starts at 9:50 p.m. Are you able to see that? Type 50 if you're able to see that new quiz which says it starts at 9:50 p.m. Okay, hopefully this will not mess up. Let's see. So we are in which question? We are in question number 4, I believe. I'm going to quickly move to question number 4 in the quiz. So first 3 questions you'll not be able to attempt once again. Let's get rid of that. Let's start off from 4. Okay. So I'm going to quickly move to question number 4 directly. Okay, the question number 4 is up in the quiz. Once please type 4 if you're able to see the 4th question, which starts with a group of 45 men. Hoping that this will not mess up. Type 4, once type 4 and then you can push off to your question, so that I'll know that things are working again. Perfect. Let's hope that things go well from now on. Does it still persist? Okay, so there is some serious issue. So we might have to check that once again. I'm not able to figure out what could have been the issue. Okay, let me figure out. I'll figure out later. So let's just solve it on the screen itself. As and when you guys give your response, I'll start discussing. So if you have got your answer, please put your answer in the chat box for this question. Okay, let's see how we can solve this question. A group of 45 men is employed to complete some work in 58 days. After 40 days, an additional 15 men are employed and the work is finished 3 days earlier. After 40 days, these things happened. Additional earlier, 45 men were there. So 15 more men were employed and the work is finished 3 days earlier. If the additional men had not been employed, how many more days would it have taken beyond the expected period? Okay, I can actually scale down this problem into a problem where after 40 days, let's see what's happening. Additional 15 men, already 45 were there. So if additional 50 men were employed, so if 60 men are employed, the work is finished 3 days earlier. It was expected to take 58 days. So if it got finished 3 days earlier, it took only 55 days. So after 40 days, it took 15 more days. With 60 men, it took 15 more days after 40 days. The question is asking if the additional men had not been employed. Okay, in that case, we will have only 45 men. Then how many days it will take is the question. Right. So let's see how many days it will take. From there, you can find out what would have been the excess. Right. So men into days. So efficiency into time will give you total work. So I could just solve it as 60 into 15 by 45. Okay. So if I cancel this, this will become 4 times, 3 times, 5 times. So that tells me it would have taken 20 days. If those 45 men were just kept as they are, it would have taken 20 days beyond 40 days. But we expected it to get completed in 58 days. I mean, that was the target initially, right? So if it's going to take 20 days beyond 40 days, then we have 2 days extra. So answer is 2 for this question. So basically, you look at what happened after 40 days. When 15 more men came, it took only 15 days from 40 because they say the work got over 3 days earlier. So 3 days earlier means 58 minus 3, 55 days only it took overall. So from 40 to 55 means only 15 days it took after 40 days. So with 60 men, 15 days, with 45 men, how many days? That's the only thing that we have to calculate here. So 20 days, which means 2 days extra. Answer is 2 for this question. Please type 3 if you're clear with why we are going with option 3 for this question. Please type R if you want me to explain this at a greater detail. I'm always willing to do that, but I just don't want to take you through the longer method in the first shot itself. Perfect. Then let's move to the next question. As and when you solve the question, please give your responses in the chat box so that I'll know who is able to answer how quickly and so on. Okay, Pawan, your R is coming pretty late. Now I'll have to shift the slide itself, which means I will stop everybody from solving. So let's wait. We already have some answers here. Okay, let's see how we can approach this question. A can do a piece of work in 80 days. He works at it for 10 days and B alone finishes the remaining work in 42 days. In how much time will A and B working together finish the work? Okay, so let's assume that total work is 80 units, right? And in that case, A's efficiency will be 1 unit. So A's efficiency is 1 unit. Now looking at B, see A worked at it for 10 days, means 10 units he would have completed. The remaining 70 units B finishes in 42 days. So B's efficiency is 70 by 42, right? Or if I cancel in, let's say, 7th table, it will become 10 by 6, or I can make it 5 by 3. Okay, so 5 by 3 is B's efficiency. Now what are we supposed to find out? In how much time A and B working together can finish the work? If they work together, then they can do this much amount of work, 1 plus 5 by 3. Total work is 80 units. So total work by their efficiency. And what is their efficiency? 1 plus 5 by 3, that is 8 by 3. 3 goes on top, 8 will cancel, this will become 10. So 30 will be the answer for this question. Type 4 if you're clear with how we got the answer as 30. Type R a little quickly if you want me to repeat before we move to the next question. Great. Looks like everybody is clear. Let's move to the next question. Okay, please try this one. Okay, some answers are already coming in. Okay, let's see how we can solve this. Very a lot of different answers. Let's see. A and B working separately can do a piece of work in 12 days and 20 days respectively. They work on alternate days starting with A on the first day. In how many days will the work be done? So A and B, their time taken is 12 and 20. So I can take LCM of these two, which is 60. I can take that to be the total work. Then their efficiency will be 60 by 12, 5, 60 by 23. This is how they will work if they're going to work together. But how are they working here? They work on alternate days starting with A on the first day. Now, the thing is, it is important to know who starts because the sum of their efficiencies is not a factor of the total work. So it matters as to who starts. If the sum of their efficiencies is the factor of the total work, then it doesn't matter who starts. This is a concept that I've discussed in the concept classes. Okay, so it doesn't, in this case, it matters as to who starts because sum of their efficiency, 8 is not a factor of 60. So if A works on the first day, then it will go like this. First day, A will come and do is 5 units. Second day, B will come and do is 3 units. And this cycle is going to continue for some time. Right? So a cycle of 8. So how many such 8s can I take out of 60? 56 I can remove, right? That is the largest multiple of 8 that I can get rid of from 60. So this cycle will go for 7 times. 8 into 7, 56. Now after that, so by the time the cycle has gone 7 times, a cycle of 2 days, it has gone 7 times. So once that has gone 7 times, 14 days would have got over. So 8 into 7, 56 units would have got over. Now that will be 15th day because 14 days are over. On 15th day, A will come to work because on all odd days, A will come to work. A is capable of doing 5 units in a day, but we don't have 5 units to be done. We have only 4 more units to be done because 56 units are already done. So A will only work for 4/5 of the 15th day. So our answer is it takes 14 days plus 4/5 of the 15th day. So it is 14 plus 4 by 5. That should be the answer. So if you simplify this, 74 by 5 will be the answer for this question. Please type 3 if everybody is clear with why we are going with 74 by 5 as the answer for this question. Now, did you notice the trap in the options here? What is the trap in the options here? One of those calculation mistakes which can generally happen. Option 2. If you look at option 2, it's 39 by 5. Right? So if you fail to multiply these number of days by 2 and just take the cycles as the total number of days, it's actually 7 times 2 days. So 14 days. If you take it as 7 plus 4 by 5 and we have 39 by 5 as the answer. You got to be a little careful. Again, I've kept telling this right from the beginning. Questions are easy would mean everybody is going to solve. Then what matters is, are you able to solve it correctly without doing silly mistakes, and are you able to solve it quickly? Keep these two things in mind. Great. Let's move to the next question, guys. And before we move to the next question, if you are liking the session, please make sure you like the video here. It helps us to reach more students. And if you haven't subscribed yet, please do subscribe. Okay, this is the next question. There's already an answer. Good, good. Let's see how we can solve this. Let me first solve like I'm sitting in an exam. Then I'll explain you what is the thought process behind that. A contractor undertook to build a road in 100 days, employed 90 men. After 40 days, he found only 1/3 of the road. Okay, so if it continues that way, 1/3 of the road took 40 days. If he doesn't interrupt and let things continue, it will take 120 days. Because it took 40 days for 1/3. So the full work to get completed will take 120 days. That's why he added more people. The question is, how many more men should be employed after the first 40 days? Okay, 120 days. Now, why am I even employing extra men here? Because 20 days it will extend by 20 days. So what I should do is I should employ some people who will do just that amount of work, which will be done in the extra 20 days with the number of people I have right now. So that extra work will be for 20 days. If 90 men work, how much work will be done in that 100 to 120 gap? Now that work I want some people to do, and those people have got how many days? 60 days now, because I'm employing them after 40 days and our target is 100 days, right? So those guys have 60 days to do that work. So I can divide this by 60. That will give us the answer. So this is going to be 3 times, 2 times, 10 times. Answer is 30 for this question. Type 4 if you're clear with how I solved this question. Type R if you want me to repeat how I solved this question. I'm finding how many days it will take if the contractor did not intervene. Okay, he noticed that after 40 days, 1/3 of the work is only over. So if he just sleeps and not do anything, let the work continue the way it is, then 1/3 of the work means 40 days. So total work would mean 40 into 3, 120 days. So 20 days it will overshoot. So those 20 days, whatever work these guys will do, we need someone else to come and do right from now onwards to cover up for those 20 days of work. So 20 into 90, because 90 men are only there without any interruption. So 20 into 90 is extra work that will be done in those 20 days. We want somebody to do that in the 60 days that we have right now from 40 to 100. So 20 into 90 by 60 will give us the answer. I hope everybody is clear. I'm not getting a lot of responses. Please type C once again so that I can be clear that you guys have got it and I can move forward to the next question. Great. Awesome. Let's move to the next question, guys. Please try this one. If you get the answer, please put the answer in the chat box. I'll know who's able to solve quickly and whether you're getting it right or not. Okay, let's see how we can solve this, guys. By now you should have solved it. Let's see how we can solve this one. Work done by P in 1 day is double the work done by Q in 1 day, and work done by Q in 1 day is thrice the work done by R in 1 day. So I'm going to put their efficiencies now. So P, Q, and R So I'll start with R because P's value is given as double of Q and Q's value is given as thrice of R. So let's take R's efficiency as 1 unit. If I take R's efficiency as 1 unit, Q in 1 day does thrice the work done by R. So Q's efficiency will be 3 unit. P in 1 day, he does double the work done by Q. So double of this, it will be 6. So their efficiencies will be in the ratio 6:3:1. This is ratio. If P, Q and R together can complete the work in 18 days. So together if these guys work, then they'll do this much amount of work and it takes 18 days to finish the total work. So that is 10 into 18, 180. The question is, in how many days P and Q working on alternate days will take to complete the work? So if this work has to be done by P and Q, now the good part here is P and Q, if you take the sum of their efficiency, divides the total work. Total work is 180 units here. If you add this and multiply, we get total work as 180 units. And if you take the sum of efficiencies of P and Q, it is 9. It is a factor of 180. So it doesn't matter who's going to start in this case. As they're working in alternate days, you sometimes have to look at who's going to start. But in this case, you don't have to worry about who's going to start because sum of the efficiencies of the two people who are going to work on alternate days is a factor of 180. And what is that? It's 9. So 180, I'll have to divide by 9. That will tell me how many cycles it will take. So 180 divided by 9, it tells me that it will take 20 cycles. And each cycle is for 2 days. So overall, it will take 40 days to complete this work. So 40 is the answer for this question. Please type 4 if everybody is clear with how we got the answer as 40 for this question. Great. Let's move to the next question then. Anybody wants me to repeat, please type R. I might be rushing through a few things here and then. I just want to make sure that I push you guys a little forward in terms of thinking about the solution. Otherwise, I can of course put things in utmost detail and explain you, but I don't want you to get used to that kind of solving. Great. Let's move forward. Let's try this one. Some answers have started coming. Great. Let's see how we can solve this one. Again, I'm first going to solve it like how I would solve if I were sitting in the exam and solving this question. A and B can do a piece of work in 45 days and 40 days respectively. They began to do the work together at their respective efficiencies, but A leaves after some days, after which B completed the remaining work in 46 days at half its regular efficiency. For how many days did they work together? Okay, when they say B did some work for 46 days at half its regular efficiency, I can tell that if he is going to work at his regular efficiency, he will take only half of the number of days. Okay, because with half efficiency, he will take double the number of days. So if he works at normal efficiency, he will take only half the number of days. So I can say B worked alone for 46 by 2, 23 days. right? See, if B works the entire stretch of work all by himself, then he will take 40 days. So anyway, B worked for alone 23 days, right? So the remaining 17 days of B's work is what these two guys did together. Okay, so what I have to find out is 17 days of B's work. This much amount of work, how long these two guys working together will take to complete. That's what I'm trying to find out now. Okay, so let's see. Let's take the values for these guys, A and B. It's given us 45 days and 40 days is the time taken by these guys. 45 and 40, so I'll have to take LCM. Let me just write it as 9 into 5, 8 into 5. So my LCM will be 9 into 8 into 5. So efficiencies, in this case, it will be 9 into 8 into 5 divided by 9 into 5. So it's going to be 8. In this case, it's going to be 9. Okay. Now, 17 days of B's work. So how much will that be? That will be 17 into 9. When both of them are working together, they will do 17 units. So I'll have to divide this by 17. We'll get the answer as 9 for this question. So 9 is the answer for this question. Please type 5 if you're clear with how we got the answer as 9 for this question. Type R if you want me to repeat what I did in this question. I found out how many days B would have taken if he is working with regular efficiency. Whatever 46 he took, that was at half efficiency, right? So at regular efficiency, only half the time he will take, which is 23 days. Normally, B is supposed to take 40 days if he is going to do the entire work alone. In the 23, anyway, he did alone. So remaining 17 days work of B, whatever B can do in 17 days, that work both of these guys are doing. So I just have to find out that if B takes 17 days to do a work, how many days A and B together will take to do the same work? Okay, let's move forward. Please try this one. You get your answer, you can put that in the chat box. Already answers are coming in. Last 30 seconds. Okay, let's see how we can solve this. If 15 boys and 20 men take 4 days to do a piece of work and 12 boys and 13 men take 6 days to do the same work, find the time taken by 2 men and 8 boys to complete the work. This is a very standard model. Questions like this have even come in the latest formats of CAT. So let's see how we can approach this. So 4 days, so 4 into 15 boys, let the efficiency of a boy be B. 4 into 15B plus 20M. That's basically time into efficiency. So that will give me what? Total work. For the next combination, 12 boys and 13 men, 12 boys plus 13 men, and they will take 6 days to do the same work. I'll have to find out how much time it will take for 2 men and 8 boys. How long they will take to complete the work. So that's the situation we have at hand here. So I can equate the first two equations because the right hand side of both the equations is TW, TW. So let's equate the left hand sides of the first two equations here. So I will get 4 times of 15B plus 20M is 6 times of 12B plus 13M. So let's cancel these things here. 2 times, 3 times. So B, it is going to be 30B here, 36B there. So 6B more on my right hand side. And it's going to be 40M here, 39M there. So 1M more on my left hand side. So 1M is going to be equal to 6B. So what I'm going to do is I'll have to find this question mark here. That's our target. So instead of having TW on my right hand side, I'm going to bring the left hand side expressions of either the first one or the second one. So let's say I'm taking the first one and replacing that for TW. So I will get 4 times of 15B plus 20M. And we know that M is equal to 6B. So I can replace M with 6B in both the cases, and then we will only have B as a variable which will get cancelled on both sides. So let's do that. M is equal to 6B. So this is going to become 12B. This is going to become 120B. So what do we get? So 12 plus 8, that will become 20B into question mark is 4 into 135B. We can cancel 4 with this, it will be 5 times. 5 I can cancel with this, which will be exactly 27 times. And B will anyway get cancelled. So I can say my question mark should be equal to 27. That's what we are trying to find out. The answer is 27 for this question. Please type 3 if you're clear with why the answer is 27 for this question. Anybody has kept track of what is this question number? We have 10 questions. I don't know what is this question number right now. Is it 8, 7, 9? What is it? It's already 10th question, is it? So are we done? Oh, we are done. Great. So we are done with the session. It's unfortunate, I don't know what happened with the quiz. I'll check that up once. It would have been better had there been a quiz so that we can see how you guys are answering. But okay, so it's nice to know that you guys are benefiting from the question. So one of the prime reasons that I would request you guys to attend the sessions is the approaches could be slightly different. Okay, approaches could be different, and sometimes it might help you. You might also have a better approach for 1 or 2 questions, and that way it's fine. But you will find that there are a lot of approaches which are slightly shorter. Okay, so once you can get hold of those approaches for various questions and you can internalize those approaches, you will see that your speed is becoming much higher than what it is right now. So for you, it's about getting the best approaches from various places, right? And definitely these kind of sessions will give you some of the good approaches to look at a question. Okay, it's not about solving. As I said, when the question becomes easy, speed becomes critical. Okay, so I'm happy that you are learning some good approaches. How many others found that the approach that we discussed in the session looks like it is slightly faster than what you did on your own? In terms of speed, right? At least for a few questions, you would have seen that there are approaches that we discussed in the session where speed can be increased really well. Okay, just getting used to that kind of thinking, that's it. Once you go through a good number of questions with that kind of a thinking, you will see that your speed is improving really well. Okay, great. So I'll catch up with you guys in the next session. Good night. Please do like the video if you haven't liked, and do subscribe as usual. See you guys.